number 59. Here we go. 59A. All right, 59A. Here, now this time, if we go back to the mole map, okay, this time we're starting at the mole station, because if you read the problem, it says find the mass of each substance, and what they're giving you in A through F are quantities of moles for each of those substances. So we're being given moles. This is our starting point, the mole, and now to get the mass we have to head back the opposite direction. So in this case, the conversion factor that applies is this guy. This is the train that's going to get us to the mass station. So now we got to flip it with respect to the one we were using in problem 58, and we have to put the molar mass on the top, 1 mole on the bottom. And that makes sense, right? Because if you're being given a certain number of moles, you want to cancel those out, so the 1 mole has to be on the bottom. And if you want to end up with mass at the end, you've got to have molar mass on the top. Okay? So again, we'll need molar mass in order to solve these problems. So in problem 59, A, 1.5 moles, 1.50 moles. And again, just to remind you, again, I hope that you're trying to work the problem first. Push the pause button, see if you can do it, and then hit play and to look at the solution. So we've got C5H12. If you remember back to when we did organic molecules, if we use the skeletal structure, we could write it like this. So it's a 5-carbon chain, and when you put hydrogens on all the carbons, that adds up to 12, right? Because you have 3 hydrogens on the N carbons. That's 6 plus 2 here, 2 here, and 2 here. So that's, a total of 6. All right, so first thing, we got to figure out what is the molar mass of that guy. Oh, my phone's ringing. Sorry about that. So you have 5 carbons at 12.0 grams apiece. That's 60, plus 12 hydrogens at 1.0 grams apiece. So that's 60 plus 12 is 72. So we have 72.0 grams per mole. And now let me change colors here. So now we're trying to figure out the number of grams, and that's equal to, okay, here's what we've given, 1.50 moles times our conversion factor. Now this time we're going to put the molar mass on the top, right? Because we're trying to figure out what is the mass of that number of moles. 1 mole on the bottom. And this way we can cancel out the moles. And that equals, let me see what I got here, 108 grams of C5H12, otherwise known as pentane. Sorry, I forgot to mention the name of this molecule. And you guys know that, pentane. Okay. And again, we were given 3 significant figures in the problem, so we can keep 3 significant figures in our answer. All right, let's go to B. 14.4. Actually, let me get a new page here. 14.4 moles of, oh, it's our friend molecular fluorine. Okay, the molar mass of fluorine, 38.0 grams per mole. All right. So the number of grams of this many moles of fluorine. So if you think about it for a second, if 1 mole of fluorine is 38 grams, and we have 14, almost 14 and a half of them, then that's going to be a number that's, well, it's going to be way bigger than 10 times this, right? So we should expect a number in grams that is, a lot more than 380 grams. I'm going to maybe throw a figure out there. Let's say it's probably going to be around 500 grams. Okay, let's see how we do. So we start by writing down what we're given, 14.4 moles. Apply the conversion factor, 38.0 grams over 1 mole. And when we take 14.4, multiply by 38.0, I get 547 grams, and that's molecular fluorine. There we go. Again, 3 significant figures here, 3 there. C. Now, I'm going to go a little bit faster. Calcium cyanide, Cn, that's a polyatomic anion. That should be in your polyatomic table. That's called cyanide. It's very poisonous, extremely toxic. If you have the compound hydrogen cyanide, this stuff is a gas, and if you breathe too much of it, you will die. And why? Because cyanide, when it gets into your bloodstream, the cyanide anion, it gets into your mitochondria, and there's a very important process in your cells where the mitochondria are, that's where your aerobic respiration takes place in your cells so that you can make ATP. And there's a very important enzyme in your mitochondria called cytochrome C enzyme. And it has an iron atom, of all things, right in the active site of this enzyme. And the job of the iron is to push electrons onto oxygen, and that's part of the cell respiration process. Well, this pesky cyanide anion, it will attach to the iron, and it binds with pretty good affinity. And so when the cyanide blocks the iron site, then that prevents this enzyme from doing its job. And and so that can be very lethal. So getting back to the problem at hand, however, the molar mass of calcium cyanide is 92.1 grams per mole. And we're being told that we have 0.78 moles, and when you work this out, the number of grams turns out to be 71.8 grams of calcium cyanide. Okay. All right. Let's go to another screen. Now we're on part D. Let me turn my page. So it looks like we have 7 moles of hydrogen peroxide, 7.00 moles of hydrogen peroxide. Okay, cool. Molar mass, 34.0 grams per mole. And when you work through the problem, you get 238 grams. 238 grams of hydrogen peroxide. Okay, A, B, C, D, E. Okay, we're given 5.6 moles of sodium hydroxide. Sorry, 5.60 moles of sodium hydroxide. The molar mass of sodium hydroxide is 40.0 grams per mole. And when you essentially take 5.6 moles, multiply it by 40.0 grams per mole, and actually, let me set it up this way. And I think you'll see that the units work out quite nicely. An alternative way of converting moles to grams is if you multiply by the molar mass with these units. I think you can see that the moles cancel out, and you're essentially going to multiply 5.6 times 40, and the answer there is 224 grams of sodium hydroxide. Okay, and finally, oops, this looks like a C. It's an E. Finally, F. Wow, a very small amount of nickel, 3.21 times 10 to the minus second mole of nickel, elemental nickel. Okay, so all you got to do here is just look up the atomic mass of nickel, which is 58.7, right? If you round it to tens place. And so when we multiply 3.21 times 10 to the minus second mole times 58.7 grams over 1 mole, you should get 1.88 grams of nickel. Okay, so if you if you guys followed all that and you feel like it's starting to become a little bit more natural, a little smoother, you are doing great. You're on the right track. Okay, and you'll be in great shape for the quiz on Tuesday. All right, so thanks for listening and good work. See you tomorrow.